Great thing. So in this one, let's look at, for example, this matrix A. And let's say we have this entry, for example, we choose it and we ask what is its value of the entry of the second row and the first column. We count the rows from the up towards down and columns from left towards right. So at this location 2, 1, which means second row and first column, which there's 2 in the original A, what is this value for A inverse? So how to get that? Well, the way we get that is basically we can use this following formula, which says if we want to get that value, so I would, for example, say that's going to be A, I, J. So the entry at a location of ith row and jth column of or let's say of the inverse matrix from the official A, then how is that calculated? Well, in the following way. It's -1 to the I plus J over determinant of the original A on the bottom and times determinant of, how could we name this? I would, for example, call it CJI. And CJI, we would call it a minor, which is basically a determinant of actually a minor, it would be including the -1 and to the I plus J. So what we're talking about is simply determinant of when we had here, for example, the second row and first column. Now we switch the coordinates as how we look at them, and we want the first row and second column, so we switch how we look at it. So this CJI will be defined as not first row and second column, but first column and second row. I switched the J and I indexes. That's the trick here. We had IJ in the input, and here we're referring to JI in the switched order. So if we are talking about entry 2, 1 in the original matrix, we will actually be using sub 1, 2 here. And all that C sub 2 numbers means is the first number is the number of column, the row number. Second one is the column number, which to remove from the original matrix A. And then what's left. So, for example, C1, 1 means we have to remove the first row and first column from A. Then we cross these two out, we only have this left. So then the determinant of C11 would be the determinant of this. So that's the whole idea, but we have a different number here. So in this example, let's make it concrete. We want the coordinate 2, 1, second row, first column. So we have 2 plus 1 here. So all this reduces to -1, -1 to the third. Determinant of CJI. So we had this coordinate 2, 1. That means now we have to switch it and remove from A the first row and second column. So first row and second column. And take the determinant of that. So that's this. Left. 2, 1, 5, 1. That's what's left. And determinant of A itself is going to be determinant of this whole matrix we have here. So let's just write it out for what it is. So determinant of 3, 1, 2, 2, 0, 5, 1, 1, 1. 1, 1, yes. So now we just mechanically calculate it. I will not go into how to calculate determinants because we would spend another lot of time for that. And we're not planning that here. The main point was to basically demonstrate this formula, this approach, not to go back to looking at determinants. That's good to review and learn in a previous, let's say, step in the learning process. So determinant of 2, 5, 1, 1. That is namely 2 minus 5, which is -3. So in the numerator we have -3. And then now let's just take determinant of A. So determinant of A, we look here, that's A. So I will do it according to the middle column, because what we have with the middle column is basically we have a 0 there, so one term will be eliminated easily by 0. So let's follow the second column. I will start with entry in the first row and second column, which is 1 on the top. So that is 1, and then determinant of the cofactor here without the, and of course, let's be careful. This is actually -1, because we have to always keep in mind that depending on according to which row or column we go, it doesn't matter, we still have to follow the pluses and minus signs in this addition. So again, this is why I'm not going in details for the determinant calculation, because we would go down another rabbit hole. So this is plus, this is minus, this is plus, minus, plus, it's switching always. This is what we are following. So we follow this column for the determinant calculation. So we have -1 times determinant of 2 minus 5. That's actually the same one like we had before. Then plus 0 times some parentheses, but it doesn't matter because it's 0. And then -1 times determinant of not that row, not that column. So 50 minus 4, which is 11. So we have 3, this is 3, and this is -11. So this is 3 over 3 minus 11 is -8. So the entry at the in the second row and first column of the inverse of A is equal to 3 over -8, or -3 over 8.